Hi everyone, today we are going to study the fusion of vertices in graph theory. So what is fusion of vertices? A pair of vertices A and B in a graph are said to be fused or merged if the two vertices are replaced by a single new vertex such that every edge that was incident on either vertex A or vertex B or on both is incident on the new vertex. So, if we have two vertices named as A and B in a graph, and if I want to fuse these two vertices into a single vertex, then it will be replaced by a single vertex, of course. That means these two vertices will be fused into a single vertex. But now we have to take care of the fact that all those vertices that were incident on A have to be incident on that single fused vertex now. Also, all the vertices that were incident on vertex B now have to be incident on that single fused vertex now. And if there is any common edge between the vertex A and B, that also has to be incident on this new fused vertex now. So that means we have to preserve the incidence of the edges and the vertices. We will not alter the incidence of edges and vertices after the fusion of these two vertices. Thus, I can say that the fusion of two vertices does not alter the number of edges. Since the incidence between the edges and vertices is preserved, thus the number of edges remain the same. The fusion of these two vertices will not alter the number of edges, but since we are fusing two vertices into a single vertex, so of course it reduces the number of vertices by 1. Let's see this through an example. I have a graph. Now this is the original graph before fusion. Here you can see how many vertices do I have? 1, 2, 3, 4, 5, 6. In total, the number of vertices that I have in this graph is 6. Then how many edges do I have? 1, 2, 3, 4, 5, 6, 7. That means I have total 7 edges in this graph. Now I will fuse vertex A and B into a single vertex named as AB. While fusing vertex A and B into this single vertex AB, I have to take care of this fact that all the edges that are incident on A. Now which all edges are incident on A? Edge 1, edge 2, edge 4. And all the edges that are incident on vertex B, that is edge 3, edge 2 and edge 6. So basically edge 1, edge 2, edge 3, edge 4 and edge 6 will now be incident on the new fused vertex AB, right? So let's write down all the vertices first. So we will write vertex E, vertex F, vertex D, vertex C, and vertex A and B will now be written as vertex AB, right? So you can clearly see, first let's start with the common edge. Edge 2 is incident on both A and B. That is, it is a common edge between A and B. So now edge 2, earlier edge 2 was between vertices A and B. Now since A and B have been fused into a single vertex AB, so now this edge 2 will form a self loop. That because it starts from AB and it ends at AB. So edge 2, that is the edge which is common between these two fused vertices, will form a self loop. Rest, okay, so the common edge has been taken care of. Now we will see all those edges which are incident on vertex A. Edge 1 is incident on vertex A, edge 4 is incident on vertex A, right? And the incidence of edge 1 is between vertex E and A. So here also the incidence of edge 1 will be between vertex E and AB. Then the incidence of vertex edge 4 is between vertex A and C. So here also the incidence of edge 4 will be between vertex AB and C. Now don't go here on the size or shape of the edge. As I told in my very first video that the shape and size of the edges does not matter. What matters is the incidence between the edges and the vertices. So here also in the original graph, the edge 4 was incident on vertex A and C, and in the graph after fusion also edge 4 is incident on the fused vertex AB and C, right? So we are done with the common edge between A and B, and we are done with the edges incident on A. Now let's look at the edges which are incident on vertex B. Edge 3 is incident on vertex B and edge 6 is incident on vertex B. Now if we look at edge 3, it is incident upon vertex B and F. So here also edge 3 is incident upon the new fused vertex AB and F. Then if I look at edge 6, it is incident upon edge B and edge D. So here also in the new graph, edge 6 is incident on AB and D. Then if you look at edge 7, it is incident upon vertices C and D. So here also edge 7 is incident upon vertices C and D. If you look at edge 5, it is incident upon vertex C and B. Here also edge 5 is incident upon vertex C and AB, because A and B are now replaced by a new vertex AB. So everywhere where A or B was coming, it will be replaced by AB. So you can clearly see that even after the fusion, the incidence of edges and vertices is preserved. Now let's see that if the number of edges have been altered or not. Here you have a 1 edge, 2 edge, 3 edge, 4 edge, 5 edge, 6 edge, 7 edge. That means total you have how many edges in the new graph? Even in the new graph, the number of edges remains same, that is 7. So clearly the number of edges have not been altered. But of course, since you have fused two vertices into a single vertex, the number of vertices will be reduced by 1. Let's see. Vertex 1, vertex 2, vertex 3, vertex 4, vertex 5. So earlier there were 6 vertices, but now there are 5 vertices. So this is the fusion of two vertices into a single vertex.